Also, 8.1 deals with polynomial functions. And y'all, polynomial just means that we're looking at expressions with many terms. So it can be a one-term monomial, two-term binomial, three terms, we call it a trinomial, and then anything else, we just generally call it polynomial, okay? So let me see. So first thing what we're going to look at is what we call the end behavior of a graph. And this looks at what the graph does as those x's approach negative infinity and infinity. So it'll be the general behavior of a graph as the x values approach negative infinity and infinity. All right, and there's basically four different shapes these graphs can take in the big picture. So we're going to make a chart, and this will be our end behavior chart. So y'all, what determines the end behavior is polynomial. So one header will have our degree. And the degree of the polynomial, remember the degree is equal to the highest exponent of the polynomial. So it's the highest exponent. So the degree can be even or odd. So we'll have two columns here. We'll have an even column and an odd column. Now, the second thing that determines the shape of our polynomials for the end behavior is the lead coefficient. So the lead coefficient. And y'all, the lead coefficient is the number that's in front of the variable that has the highest exponent. So the lead coefficient can be positive or it can be negative. So these two columns and these two rows will determine our end behavior. So y'all need to give us four different pictures. So the x squared graphs we've been drawing in the last section. X squared graphs are even. So even degrees, if the lead coefficient is positive, both ends of that graph will head towards positive infinity. So if it has an x squared as the highest exponent, x to the fourth, x to the sixth, if that number in front is positive, both ends will go up. And then y'all, when we was doing our transformations, if the lead coefficient was negative, that took our graph and sort of flipped it over the x-axis. So if that lead coefficient is negative and it's an even degree, both ends of that graph will head towards negative infinity. So notice as my x's get larger, my graph heads towards those infinities, okay?
What did you say a lead coefficient is?
All right, let me let some in real quick. So let me break that down real quick for y'all about a lead coefficient. So let me just draw a polynomial here. So say I had P of x equals 3x to the 6th minus 4x to the 3rd plus 2x minus 1. So here's my polynomial. So notice the highest exponent on this is a 6. So that means that my degree is 6. So remember the degree, like we said, was the highest exponent. Now, the whole term, and these are terms, the 3x to the 6 is the term, negative 4x to the third is a term, 2x, and a negative 1. So since the degree was in this first term, this whole term now is what we call a leading term. So this would be the leading term, because it's the term of the polynomial that had the degree. This 3 in the front is what we would call the lead coefficient. So the lead coefficient is the number in front of the variable that gives you that degree. So,
Okay, thank you.
So on this one that I actually drew, my degree would be even. My lead coefficient 3 would be positive. So that tells me that in the long run, this graph on both ends will head up towards positive infinity. Now, the higher the degree is, there's a lot more terms that happen on the inside. But we're not worried about all them terms. We're just worried about that end behavior. All right, so did that fix y'all on that lead coefficient stuff? All right, y'all. So if they're odd were the graphs that were symmetric to the origin. So if the degree is odd and the lead coefficient is positive, those graphs look like they're going uphill, left to right. And then if that lead coefficient was negative and the degree is odd, it sort of flips this one over so that it sort of looks like it's going downhill, left to right. So y'all, I'm just going to, for the next few examples, I'm going to call this A, B, C, and D. So that way we can use this chart to sort of answer some of their questions. So they're going to give you something and it's going to say, select one of the following sketches that describes the end behavior. So we're going to select the sketch that describes the end behavior. All right, y'all. So for my first one, I'm going to do f of x equals a square root of 5 x to the third plus 5x squared minus 3x plus 3. So we're going to choose A, B, C, or D. So the first thing I would ask y'all, what is the degree of this polynomial?
3.
So the degree is 3. Because y'all right there is my highest exponent. Now my lead coefficient
Five.
So my lead coefficient, would it be positive or negative?
Positive.
Positive.
Because that's a square root of 5, so that is definitely a positive square root of 5. And altogether, this was what we considered the leading term. So it has my degree of 3, which is odd. So that is definitely odd. Y'all said the lead coefficient was positive. So if I got an odd degree, positive lead coefficient, would y'all go A, B, C, or D?
B.
B for sure. There you go. So B has it going sort of uphill, left to right. And so on those, they'll give you the 4 pictures and you're just going to pick which one has what you need. All right, I'm gonna pull this down just a little bit to get another one here. All right, so doing the same thing, f of x equals negative 4.5 x to the fourth plus x to the sixth plus 0.8 x to the eighth. So we want to figure out our degree and our lead coefficient. So what would y'all put on the degree of that one?
8.
Oh, what y'all just say?
8.
8 for sure, because that's my highest exponent. So the degree is 8 is even. That means, y'all, you got to look at this as the leading term, which means my lead coefficient, would y'all put positive or negative?
Positive.
Positive.
Positive for sure. So y'all, they try to trick y'all by throwing them out of order and making you think that since this was the first number, it's the lead. But remember, the lead coefficient is always in front of the leading term. This one, they just put out of order on us. All righty, so even and positive, A, B, C, or D.
A.
So definitely A. So we had what, both ends going uphill. All right, so y'all, that's what you got to watch out for is when they're out of order, find that term that has that highest exponent and then work everything off of that one. All right, y'all, so next, we're going to use substitution to determine whether a number is a zero. So we're going to use substitution to determine if a number is a zero of a polynomial. If the number is a zero, then the function value must be. So here's the thing. If it's a zero, when I plug my number into that expression and I evaluate it, then that function value must be 0. And y'all, that's one thing we did learn about zeros. Remember, zeros were equal to the x-intercepts, which means those had y values of 0, okay? So the problem they're giving us, they want to know, is 5 a zero of f of x equals x to the third minus 12x squared plus 14x plus 105. And y'all, to determine that, since 5 is the number I'm checking, we're going to be finding f of 5. Which means I'll take this polynomial and put a 5 in for every x there. So I'm going to get 5 to the third minus 12 times 5 squared plus 14 times 5 plus 105. All right, so the question is, does this equal 0 or not?
Probably not.
All right, well, let's see. What's 5 to the third power?
125.
So that's 125. Now, at the moment, all I'm going to do is these exponents here and here. So I'm gonna bring minus 12 down. And what's 5 squared?
25.
All right, y'all, then I'm bringing everything else down, and I'll do all my multiplying in this next step. All right, so we got 125, can't do nothing with that at the moment. How about 12 times 25?
300.
All right, so that'd be 125 minus 300. All right, y'all, how about 14 times 5?
70.
And then at the end, I'll bring down my 105. All right, so let's see what we get. 125 minus 300, that right there gives me a negative 175. That negative 175 plus 70, that's going to bring this down to a negative 105. Oh, and y'all look at that. Negative 105 plus 105. That gives me a big O 0, which means yes, 5 is a 0 of that polynomial. So y'all, that's all you're doing on that, and just plug your number in and see if that is a 0. Any other number, how to put a no on that, okay? All right, so so we now remember zeros are what we call the solutions of our quadratic equations. Same thing applies with the polynomials. We still get 0 for those values. But y'all, a new word for us in this section is multiplicity. So multiplicity is the number of times that a 0 occurs. Okay, so remember when I had those what was those, say x plus 2 squared, if I was to solve x plus 2 and set it equal to 0, I'd have got a negative 2 for the 0, but it would have had a multiplicity of 2 because it was being squared, and I would have had 2 sets of them parentheses, okay? So just remember, the multiplicity is just how many times my 0 occurs. Now, other things this multiplicity tells us, if the multiplicity of a factor is even, then the graph is tangent at that 0. If the multiplicity of a factor is odd, then the graph crosses the x-axis. At that 0. So I'm just going to show you what I mean by that real quick. So say, and I want to show you what I mean by tangent and crossing over.
Can you give me just a second to write it, if you don't mind?
Excuse me?
I said, can I have just a second to write it?
Oh, yeah. I'm just going to get me a drink, and then I'm going to draw us a graph. All right, y'all. So my graph is going to come up. Well, let me get it going. It's going to cross over the x-axis. And then it's going to cross through the origin. And then this one's going to sort of come up and come down. So this one, see how both ends are going down? This one would sort of been an even degree with a negative lead coefficient, would have made both ends go down. But y'all see this point right here and this point right here where the graph is crossing over my x-axis. For it to do that, it would have had an odd multiplicity. So these happen from the odd multiplicity. And notice the graph is just crossing right over that x-axis. But y'all, this point right here, the graph sort of comes up, touches that x-axis, and then turns back down. We say that this is tangent. So right here, to get this point, I would have had my even multiplicity. So remember, even multiplicities touch that x-axis and they turn back through. They do not cross over it, only if it's got an odd multiplicity. So I'll let y'all get that, and then we'll start looking at questions they're going to hit us with on those, okay? All right, y'all moving on next page. All right, so for this example, they want me to find the zeros. And state the multiplicity of each. All right, one must have got knocked off here. So find the zeros and state the multiplicity. All right, so I got f of x equals x squared minus 4 in parentheses raised to the 5th power. So remember, that 5 tells me that I got an x squared minus 4, x squared minus 4, x squared minus 4, 5 times. So the first thing I want to do on this is actually find the zeros. And to find the zeros, you take each one of these factors and set it equal to 0. So I'm going to set x squared minus 4 equal to 0. And we're going to solve that for the x. Once I solve it for the x, I got the solutions or the zeros, and then I'll figure out what their multiplicity is. So y'all, the easiest way to solve this when you got an x squared term and a number is to get the x squared term by itself and then do square roots. So to get the x squared term by itself, I'm going to add 4 to both sides. So that's going to give me x squared equals 4. Now, let's take the square root of both sides. So square root of x squared is x. So y'all, what's the square root of 4?
Is it 2?
Oh,
Is it 2?
What y'all just say?
Is it 2?
That's one of them.
Or negative 2, I think.
There you go. So I'm actually going to use the plus or minus 2 on that. There you go. So remember, now that we're looking at x squareds, we got to get 2 answers because that's a 2 sitting up there. So we got to take into account our plus and negative 2's. All righty. So those are your zeros. And each has a multiplicity of Well, how many times did them 2 zeros happen? So y'all, when you're looking for the multiplicity, you're looking at these exponents on the outside. Remember, that 5 tells me that I got this x squared minus 4 5 times, which means these 2 zeros each have a multiplicity of 5. Now, you could have wrote it out 5 times and then solved them all, but you'd have still got these 2 answers every time, okay? All right, y'all, let's try this one. F of x equals x to the 4th times x minus 4 squared times x plus 8. Now, we'll say these exponents like the 4 here, the 2 here, those are my multiplicities. Y'all, there's not an exponent following the x plus 8. So what exponent is it understood to be out there?
1.
It is definitely a 1. All right, so what we got to do now is find, we got 3 factors here, so we got to find 3 zeros. So we take the x and set it equal to 0. We take the x minus 4, set it equal to 0, and then the x plus 8 equal to 0. Anytime you got a single factor like this, x to the 3rd, x squared, x to the 4th, x to the 5th, if it's a single factor like that, it will always equal 0, and that exponent will always be its multiplicity. Now, the other ones, you actually got to solve them. So the first one here, I'm going to add 4. So my second 0 is 4, and y'all, the third 0, I'm going to subtract 8. And I get a negative 8. So let me show you how they want this answered. It says the smallest 0 is blank with multiplicity blank. Then it'll say the middle 0 is blank with multiplicity blank. And then the largest 0 is blank with multiplicity blank. All right, so let's see what we got. We got a 0, a 4, and a negative 8. So that means my smallest 0 is what?
Zero
X plus 8.
or negative 8.
So the negative 8, good job. And it has a multiplicity of what?
1.
1, there you go. And that's why you always got to visualize that as a 1. Some people will think, well, there's no exponent there, so they make that a 0, but no. If there's not an exponent, it's always a 1. All right, so what is the middle 0?
0.
0,
And it has a multiplicity of?
4.
4,
And then y'all, we got one more. The largest 0 is blank with multiplicity blank.
4 with multiplicity of 2.
There you go. So y'all, they're not that bad. You just got to sort of get them 0 solved for and then answer how they got. So watch this one. This one they're giving us f of x equals negative 5 times x minus 5 squared times x plus 2 to the third times x to the fourth. So we'll get our zeros and then we'll see how they got these answers. All right. We're only concerned with factors that have variables. So y'all see this -5 sitting in the front? It has no variable with it, and there's no way I can set a -5 equal to 0. So that -5, we can sort of cross that out. It has no bearing on our zeros or the multiplicity, okay? We're only concerned with the terms that have the variable. So first I will take the x minus 5, set that equal to 0. The x plus 2, set that equal to 0. And then here's my variable term. And remember, on the single variables, all I got to do is take that x and set it equal to 0. And y'all, once again, up here, the variable term gave me 0. Down here, the variable term is going to give you 0, okay? So we'll solve these by adding 5. Subtracting 2 from the next one. All right, and then that one gave me a 0. So let's see what they want. It says the 0, 5 has multiplicity blank. Then it says blank is a 0 of multiplicity 3. And then it says the remaining 0 is blank. It has multiplicity blank. All right, so y'all, let's see what y'all about to put in this blank. So the 0, 5 has a multiplicity of what?
2.
There you go, 2. So you got to look up here at which factor we got that 0 from, and we got it from the x minus 5 factor, and there was its multiplicity sitting on the outside of a 2. All righty, how about this one? Blank is a 0 of multiplicity 3.
-2.
So -2, because that's the 0 we got from the only factor that had that 3 sitting by it. All righty, so how about that? The remaining 0 is blank, and it has a multiplicity blank.
0 and 0.
Oh, you're so close. I got that 0, but what was its multiplicity?
X to the 4.
4.
So all you need is that 4, y'all.
I got a question on that first example.
Yeah.
That middle 0, how is it the 0 instead of the 4?
Oh, because remember, they're looking at remember, negative numbers on the number line are way over here to the left.
So you're going left to right pretty much.
And then you got 0 in the middle, and then to the right would be my 4.
All right, gotcha.
So they're looking at them like they would on the number line on those, okay?
Appreciate it.
Okay. All righty, y'all. So now, I guess MathLab was acting nice on those examples. They already had them factored. But y'all, now, these next 2 examples, we're going to have to factor them to find the zeros. So for this example, they want us to find the zeros and their multiplicities. So it's basically doing the same thing, except they're going to make us do more work to find our zeros. So they're giving us f of x equals x to the third minus 5x squared minus the x plus 5. So y'all, this has to be factored. They gave me a polynomial and we're just going to have to factor this. Now, we'll play with x cubes on this. Anything higher than an x3, we'll learn how to find their zeros in the next class when we do what we call synthetic division. But for this x third 3-degree polynomial here, I'm actually going to do what I call factor by grouping. I'm going to use factor by grouping to solve this. So y'all, the first thing you do where it gets its name is you group these first two terms together and then you group them second two terms together. Okay. So that's where this gets its name. Now, what I want to do now, so basically my first step is to factor out the GCF of each group. So I got two groups, so I'm going to factor out the GCF, which is the greatest common factor from each of these two groups. So y'all, let me ask you this. You got an x to the third sitting here, and you got a negative 5x to the second sitting there. What is the largest factor that they have in common?
PC,
Oh, what was it?
15. 3 or 5.
So
Would
let
it
me,
be 5?
so let me go this way. Remember, x to the third is what? X times a x times a x.
Would it be x to the second?
X to the second, because both of them have at least two x's as the factors. So y'all, we would factor out that x squared and put what's left of these two terms in the parentheses when you take out that x squared. So if you had an x to the third and you took out x squared, what's left?
X.
And that's going to be minus. Over here, I had a 5x squared. If I take out the x squared, what's left?
5.
There you go. So that takes care of the first two terms. So now we got to work the last two terms. Now here's a rule on this. The second GCF always has the same sign as the third term here. So second GCF has the same sign as the third term. So since my third term was negative, that automatically made this negative. Well, let me ask y'all this. What is the greatest common factor between an x and a 5?
1.
1.
1. There you go. Second GCF has to at least have a 1 in it. So we would break out that negative 1. So if you had a negative x, you divide that by a negative 1, what's that going to leave me in my parentheses? So negative by negative will make that a?
Positive.
Is it negative divided by or multiplied?
You're basically dividing out those GCFs.
Mm-hmm.
So the negative by negative made that positive. But how about this positive 5 when you divide it by negative?
It becomes a
Negative.
-5.
It becomes a negative 5. So now we were really doing that with the variables here, but remember when you divide variables, all you're doing is subtracting exponents. So 3 minus 2 left me to 1x, and then there's 2 minus 2, sort of got rid of the x's on that one. But y'all, what do you notice about my parentheses? They
Like
match up.
term.
These parentheses match up, right? So
Mhm.
at this point, it's very important that your parentheses must match up. So the parentheses must match up. So if you treat this like two terms now, you got an x squared times x minus 5. You got a -1 times x minus 5. Between these two terms, what is their greatest common factor?
One.
Well, think about this. What matches for both of those?
5. -5.
5.
Well, how about the whole thing? The
X minus 5.
Yeah, so since both of these have the same factor of x minus 5, we're going to factor out that x minus 5 like we would a GCF. So if you factor out that x minus 5, what's left for my second parentheses?
X squared minus 1.
X squared minus 1. So y'all, that's the trick. Since the parentheses match, we sort of pull them out as a GCF, and then everything else goes here. So now we got our factors. I'm going to take both my factors and set them equal to 0 now. So now we're just basically finding those zeros, okay? So the first one, y'all, we're going to add a 5. And again, x equals 5. Now, y'all, the second one, since that's the x squared, I'm going to try to get the x squared by itself again by adding 1 to both sides. And we get x squared equals 1. And then we're going to do the square root. So y'all, square root of 1 would give us what?
1.
Plus or minus 1.
Plus or minus 1. Good job. So for the answer on this, the zeros are blank. Each zero has multiplicity blank. So what's my zeros? Now remember, that was an x to the third. So I better have 3 zeros, because remember, the highest exponent usually tells you how many zeros you have. Well, here we got a 5 for one of them. I got a +1 and a -1. So y'all, the multiplicity I can find when they're up here is factors. There's no exponent behind either one of these parentheses. So what exponent is there?
I have a question.
1.
Is it 1?
That's going to be a 1. So that means each one has a multiplicity of 1. All right, so what was that question?
Never mind. I figured out how you got the zeros.
Okay, yeah. So what you got to watch for, if you got a single x, usually you just add or subtract to get that 0. But when you got these x squareds, that's when you got to either take square roots, do the quad formula, or some way to get that solved, okay?
So basically you got the zeros from the equation, so that's what, 5,
Uh-huh.
1 and -1.
Yes, ma'am.
Okay.
So y'all, let's have another one of these, because you can never do too many of these 4-termers. So let's see what we got here. Same thing on this one. We got f of x equals 6x to the third minus x squared minus 96x plus 16. And you'll notice this has an exponent of 3 again, so I'm expecting at least 3 zeros for this. And y'all, we're going to do the same thing here. We're going to group the first 2 together and the last 2 together. So we got a 6x to the third and a -x squared. What is their GCF?
X squared.
All righty. So let me ask you this. If you factor out an x squared, what's left from the first term?
1.
6.
So 6x. Yeah, 1x, but remember, you always bring down that 6 also. Now look at this one. You got an x squared. If you divide by x squared, what's that leaving me?
Negative x.
1.
Well, not a negative x, but a -1. There you go. Because remember, that thing's dividing by itself on that part, okay? All right. The next GCF, remember, has the same sign as the third term. So my next GCF will be negative. So y'all, I'm going to give you a trick on this, and because 96 and 16, their GCF is pretty big, I consider. But look what you have to have in the first one. You got to have a 1 there, don't you?
Yes.
So I'm looking at this 16. What can I divide that 16 by to turn that into a 1?
16.
16. So I'm going to see if that 16 will go into that 96. So one of y'all divide that 96 by 16 and see what we get left.
6.
And we know we better get a 6 because remember, that's what's in that first parentheses, right? So 96x divided by 16 leaves me a 6x. And then y'all look here, 16 divided by -16 makes that a -1. So let me see if y'all remember what I'm about to do. I'm about to write this as 2 sets of parentheses. What's going in each parenthesis?
6x minus 1. X squared minus 16.
X squared minus 16. There you go. All righty, so I'm basically now at the point where I'm going to solve these. So once again, what's the multiplicity is going to be for each of these parentheses?
1.
So there's like a 1 there and a 1 there. All right, y'all, so here we go. 6x minus 1 has to equal 0. X squared minus 16 has to equal 0. Oh, so it looks like we got a little more work on it this time because that number in front. So what are we going to do? Add 1 and then divide by 6. So y'all, looks like I'm getting a 1/6 on that one. Then over here, remember that's an x squared. So I'm trying to get that by itself by adding my 16. And then I'll square root this. So square root of 16 is
Plus or minus 4.
plus or minus 4. So y'all, we will do the same thing up here. Zeros are blank. Each 0 has multiplicity of blank. So what's my zeros?
1/6 and +4 and -4.
All righty. And then each 0 has a multiplicity of
3.
1.
1.
Or 1.
yeah, y'all told me 1's on those, so remember. Don't go back to your polynomial, just play with the multiplicities when you get them factored out, okay? All right, I'm gonna let y'all catch up real quick on that. So my last two are gonna be true and false based off of what I told y'all earlier about these multiplicities. All right, let's see. I done did that sign on that. All right, so this is going to be true or false. So if P of X equals X minus 9 to the 8th times X plus 2 to the 7th, then the graph crosses the x-axis at the point 9, 0. Yo, is that true or false? So I'll show you how I would do this one. 9, 0 is my x-intercept, which means 9 is the 0 they're looking at. So the only factor that has anything that could possibly be a 0 of 9 is this factor of x minus 9. So I'm looking at its multiplicity of an 8. So a while ago, when I was talking about multiplicity, if it was even, it did one thing. If it was odd, it did something different. So for the even ones, I said for even multiplicities, those zeros were tangent to the x-axis. If they had odd multiplicities like this 7, then they would cross over the x-axis. But y'all, they're focusing on the 9, 0, which comes from this factor. That is an 8, which is even. So in reality, this one is tangent. So this would be false. Since 8 is even, that makes it tangent. So that means it will just touch that x-axis and turn back up. So this one I'm going to let y'all answer. If P of X equals X minus 6 to the 3rd times X plus 2 to the 10th, then the graph is tangent to the x-axis at the point -2, 0. So y'all, is that one true or false?
True.
True.
That is definitely true, because that -2 came from this factor over here, which was x plus 2. You got a 10 sitting there, which is even. And we said even ones were tangent. So that one you would put true, since 10 is even, the graph is tangent. Okay, y'all, so for the last little part, I'm going to give y'all some definitions for what you're needing to support stuff. So this is just to help you with your support lesson, okay? So we got what we call classification of polynomials. Okay, so we got what we call a constant polynomial. To be a constant polynomial, it's just going to equal a number. Something like P of X equals 5. Okay, it could be any number, but it has no variables. If it has no variables, it's a constant polynomial. Linear looks like a line. So to be linear, you'll have something like x plus 2. So now, and then I'll show you what the degrees of these are. So if there's no variable here and it's just a constant number, the degree of this is 0. Y'all, what exponent is by this x up here since I don't have an exponent?
1.
So that means this has a degree of 1. Quadratic is next. So those would be like your P of X is equals something like x squared minus 2x plus 3. That means the quadratic has a degree of 2. Next is cubic. Cubic could be a P of X equals x to the 3rd minus 8. But notice a cubic has a degree of 3. And then, y'all, the last one they'll ask you on these questions is what we call quartic. Sort of like a quarter. So that could be a P of X equals 2x to the 4th plus 3x minus 2. But notice it has a degree of 4. Okay, so remember, they're going to ask you to classify your polynomial. They'll ask you the degree. And then remember, the leading term and leading coefficient. So if I was looking for the leading term on the last one I did, the leading term, since 4 is the highest exponent, the leading term would be the whole part, 2x to the 4th. The degree would be the 4. The lead coefficient would be the 2. Okay. So all that lead stuff comes from the term that has your degree in it. So y'all, that's what they'll sort of do. So an example of a support question, they might do something like this. Given P of X equals negative 2x to the 3rd plus 7x squared minus 3x plus 4. They want to know the degree, the lead coefficient. We'll even do the leading term. And then we'll classify it. All right, y'all. So given this polynomial, what is its degree?
3.
3.
3, because that's my highest exponent right there. My lead coefficient.
2.
-2.
So -2, put that negative in there, okay? All right, my leading term.
Would it be 7?
Oh, so remember, the leading term is the whole part where you got that degree from.
-2x to the 3rd.
-2x to the 3rd. There you go. So based on this polynomial, is it constant, linear, quadratic, cubic, or quartic?
Cubic.
Cubic, because you got a degree 3, and degree 3s are always cubic. There you go. So y'all, that's what this support's going to hit you with, a little bit of this. There's not but like probably 4 or 5 of those, and they're pretty quick. And then the 8.1 for college algebra has the end behavior chart in the beginning, and then it gets into the zeros and the multiplicities, okay? So it's not too bad. Next class, we'll do 8.2 and 8.3. They're pretty short sections. So we'll do both of them on Wednesday, and then that'll be it for this week. All right, y'all. So we're to the point where, what questions do y'all have? And let me stop my recording real quick so we can that'll be loading to the cloud.